students, welcome to the another session. In this session, we'll be discussing about the concept of areas. Okay, so if you have certain thing like this, and I need an area between these two. Happily, I can divide into quadrilaterals or triangles. You can find the area. But when the curve is like you have like this, how we find this area. So we will be taking a small portion of this one and we call it as dx and a to b. So integral of this way it is area dx into this one is f of x. Okay, so f of x into dx stretched between a to b. So this one gives us the area. When I am doing this one, you need to be careful. What are the necessary steps we need to take? We'll be discussing now. Y is equal to f of x is continuous in the interval a to b. For all x belongs to a to b, f of x greater than 0, then the area bounded by y is equal to f of x with x axis. So this is the, let me change the color. So this is the f of x. I need between x is equal to a and x is equal to b with x axis. Simply, this answer is integral a to b f of x dx. Integral f of x dx. Okay. Now, if f of x is negative, if f of x is negative, f of x is negative means the curve is like this. So when you are taking this one, because this is below y-x axis, automatically this value will become as a negative. But area means positive quantity. To avoid that one, we are writing this minus sign. We are writing this minus sign. So to make it this one, maybe you can write integral a to b f of x dx is also advisable, but sometimes, okay, this is always preferred one. Is it always preferred one? No, this is not always preferred one. What is preferred one is integral a to b modulus of f of x dx is preferred. Why? That one we look at with the next slide. Look at here. The curve is like this. So area is, look at here, till C is positive. So when you take this is the positive area will come. During this time you will get positive area. But during this time you will be getting the negative area. You will be getting the negative area. So how we will be doing this one? We will be doing this one integral a to c f of x dx minus integral c to b f of x dx. Because this negative area, to address the negative, we will be doing this one. Or maybe you can write integral a to b modulus of f of x dx is also preferred one. But again, what is modulus? Again, you need to split into this part only. Next, you look at this curve. The problem with this curve is with respect to x-axis, we cannot find. This curve is more like. So what you can do with respect to y, we will be doing integral a to b f of y dy. Okay, again, if this is positive, we will be taking this one. If this is this negative side, automatically we will be taking negative sign. So positive or negative, depending on the situation, we can take it up. Here only I want to tell you one more diagram which most of the times you'll get. For example, you have a curve like this. Okay, I need to find this area. So it is better you can go ahead with this area. Okay, next one is if there are two functions are there, y is equal to f of x, y is equal to g of x, area bounded by these two. So irrespective of which is better, what I do is I'll take the modulus because I'm not sure whether, okay, here we mentioned y1 is greater than y2. But if you are not sure whether f of x greater than g of x or g of x greater than f of x, happily you can go ahead with integral a to b modulus of f of x minus g of x dx. So here you'll get like curve like this. I need this area. So if this is a, this is b. So this is f of x, this is g of x. Simply integral a to b f of x minus g of x. When you are doing graphical way, whichever the high upper side, that is the maximum one, whichever the downside, that is the lower one. Look at here. I am trying to cover all the things. F of x is this one, g of x is this one. I need between x is equal to a and x is equal to b. So between x is equal to c is there. So what you are going to do? Simple integral a to c f of x minus g of x dx. This is the one thing, plus integral c to b f of x, sorry, g of x minus f of x dx. Or you can also you can write it as integral a to c sorry a to b modulus of f of x minus g of x dx. Okay, next one is some standard properties for your betterment. Area of the region bounded by y is equal to ax square plus bx plus c, where delta is b square by 4ac, b square minus 4ac. So the curve is this one and x-axis. Okay, and y is equal to area of the region bounded by this one, and y is equal to mx plus k. In this case, this one. Okay, y is equal to mx plus a, where delta is the discriminator. So I don't suggest you to remember this one. Why? There itself you can find out these values and do, because that much may not be. Maybe some extent this is fine. Y x is equal to ay square plus by plus c. Again, you can go ahead with this one. Okay. But if you have any doubt here, power is 3 by 2 or 2 by 3, such thing, don't do. There itself simply you can solve the question. Right. Circle, area of the circle is pi r square or pi a square. Area of bounded with y square is equal to 4x, x square is equal to 4by is equal to 16ab by 3. And here origin is shifted to some other point, y square this value. Area of the ellipse is pi ab. Area of the ellipse is pi ab. Area of the triangle formed by tangent normal at x1 y1 and x-axis. So area of the triangle formed by the tangent and normal at x1 y1 x-axis, where the slope is m. So what is this one? With the slope m, x1 y1 is there, this one will be there, x1 y1. So you can write it as y is equal to, or y minus y1 is equal to m into x minus x1. See, simply this value is equal to y1. You can find out what is the x-intercept here. Similarly, y minus y1 is equal to minus 1 by m into x minus x1. You'll get this distance, half of this distance into base height is equal to, you'll be getting this value. Okay, if y-axis is there, this line will be there, y-axis will be there, so this value will be equal to x1. You can write what is the x and y intercept of this line and this line. Accordingly, you can find out the values there. Okay, next, this is a parallelogram. This is a1x plus b1y plus c1 is equal to 0, and here a1x plus b1y plus d1 is equal to 0. Similarly, this will be there. So actually what happened, this height is p1, and if you take this one is p2, this area will be equal to p1 p2 by sine theta. Based on that one, you will be getting c1 minus d1 into c2 minus d2 by a1 b2 minus a2 b1 whole modulus will come for the area of the parallelogram. Y is equal to area of the area of the one arc of the curve. Actually, what happened, if you take y is equal to sine x 0 to pi by 2 sine x dx, this value is equal to 1. Y is equal to sine ax, and x-axis in the interval 0 to n pi will be equal to 2n by a, because periodicity, due to periodicity, those things will come. And in areas, the major thing is drawing the graphs beta. If the curve is symmetric about x-axis, what is the mean? Symmetry means x comma y lies on the curve. Automatically x comma minus y also lies, because symmetric about x-axis. Symmetric about y-axis is for every x comma y, minus x comma y also lies on the curve. Okay. Derivative of a. See, its inverse function always symmetric about the a function y is equal to f of x and y is equal to f inverse of x. They are symmetrical about. They are symmetrical about y is equal to x line. Always y is equal to x line. And here also we need to know few points for betterment of the drawing the graphs. Okay, f of x is there, y is equal to f of x. Always y is equal to f of x minus a. So the graph will move this direction by a units. Y is equal to f of x plus a. The graph will move this unit by a units. Y minus b is equal to f of x. The graph will move this unit by b units. Y plus b is equal to f of x. The graph will go this by b units. Okay, and how to look at the modulus function graph is also important, and you need to know the periodic functions also, and fractional part of x also you should know for this topic. So let us look at some of the questions on areas. The first question is area under the curve x square plus y square is equal to 16 and the x-axis. So this is the curve like this and x-axis. So total area is pi r square. So total area is 16 pi. I need only this half of this. So you are going to get that one as 8 pi. Next question is area under the curve, same circle only, but the difference is x-axis, x is equal to 0 and x is equal to 2. So you require this area. 1/4 of the total. So answer is equal to pi r square by 4. Pi r square by 4 means you are going to get answer as pi. Next question is area bounded by the circle x square plus y square is equal to 4 in the first quadrant. So this is. Apart from this, so 1 minute. So along with this one, they have given one more line also. What is that? Y is equal to root 3x. Area bounded by circle in the this one and x-axis. So this is one boundary, this is one boundary, and this is one boundary. I read this one. So radius is pi by 3. How can you say slope is root 3? So answer is of, okay, r square theta is equal, theta should be in terms of radian. R square is 4 and this is pi by 3. So the answer is going to be 2 pi by 3. Next question, area bounded by ellipse. This equation is x square by 4 plus y square by 9 is equal to 1. Area is pi AB. So here 3 2s are 6. 6 pi will be the answer. Okay. Next question. Area enclosed by positive quadrant, in the positive quadrant by x by a plus y by b is equal to 1. X square by a square plus y square by b square is equal to 1. So this is the ellipse and I need this one. So what happened? Area enclosed in the between this. So I need this one. I need this one. You know total area is pi AB. But if I take this one, 1/4 of this minus area of this triangle is of AB. So if I take AB by 4 common, then you are going to get pi minus 2 as the answer. So I need this area. I need this area. Okay. Area bounded by this one. So you people need to remember one thing. Y square is equal to 4ax and x square is equal to 4a1. So this point is 8 comma 8. This point is 0 comma 0. Okay. Right. So simply you can write it as 0 to 8. Y is equal. This is y square is equal to 4x. So y is equal to 2 root 2 x minus, here y is equal to this portion, x square by 8 dx. You can take this one. Directly what happened? Y is equal to here, it is 4ax 4ay. Actually, if you have the formula, y square is equal to 4ax and x square is equal to 4ay or 4by. The answer is going to be, okay, 16ab by 3. That means 8 into 8, 64 by 3 is the answer. So 16ab by 3 is that area. Next question is area bounded by parabola y square is equal to 4ax and lattice rectum. So what I'll do, I require total area. So I will take this portion. I'll take this portion. X is equal to a. So what will happen? Required area is 2 times integral 0 to a, 2 times integral 0 to a. What is y is equal to 2 root a into root x dx. So this value will be 4 root a into x to the power of 1 by 2 is 2 by 3 into x to the power of 3 by 2. So you substitute the limit 0 to a. So it will be equal to 8 by 3 a square. So answer is going to be 8 a square by 3 is the answer. Next question is area bounded by y square is equal to 8x and the line x is equal to 2. Please understand, if you recollect the previous question, very simple, because your x is equal to is the lattice rectangle. So it is integral of root 8 2 times of root 8. I am taking this portion 2 times 0 to 2 into root x dx. Happily you'll get 4 root 2 into 2 by 3 into x to the power of 3 by 2. So this is 8 by 3 into this value will be 4. Okay, just a minute. What will happen here? 2 root 2, 4 root 2 and this one. Area bounded by this line. So what is the root 2 into here 2 root 2 will be there. So answer will be equal to 32 by 3 should be the answer. 32 by 3 should be the answer. So answer should be 32 by 3. It should not be 16 by 3. Okay, this is wrong. Next question. Area bounded by the curve x square is equal to 8y. This curve will be like this. X is equal to 4 and x-axis. So x is equal to 4, y is equal to 2. This is 4 comma 2. So area bounded by this means I need this area. I need this area. So what you can do, integral 0 to 4, what is y? X square by 8 dx, which is equal to x cube by 24 of the limit 0 to 4, which is equal to 64 by 24. 8 8s are 8 3s are. So answer is 8 by 3 units. Area bounded by sin x between 0 to 2 pi. Area bounded by. So you should not take 0 to 2 pi sin x dx. Actually, if you take, this answer is going to be 0. But what is area I need? So area means integral 0 to 2 pi. Actually, you need to take mod sin x dx. Or what I'll do is, if this is the x-axis, sin x will be like this. So this area into twice, actually integral 0 to pi by 2 sin x dx is equal to 1. So this is 1 unit, 1 unit, 1 unit, 1 unit. So the answer is going to be 4 units. Answer is going to be 4 units, because if I take like this, this is not the area. So you cannot take this one, you have to go for this. So with this one, I'm concluding. Thank you very much. With another topic, another session. See you. Bye.